Here's a second example, and this one I have all worked out. The number of inmates in custody in U.S. prisons can be modeled by f at x equals negative 716.2 x squared plus 87,453.7 x plus 1,148,702. F at x is the number of inmates, and x will be the number of years after 1990. So suppose I'd like to figure out when the maximum number of inmates will occur and what the maximum number of inmates is. Well, again, this is a quadratic. I see the square, and I also notice my leading coefficient is negative, so my parabola is concave down. And so I'm looking for the vertex. So again, I start by finding the x, and I use negative b over 2a, so that's negative 87,453.7 divided by twice negative 716.2, and if I do that I get 61.1. And again, that's x, so that's the number of years after 1990. So the maximum number of inmates will occur 61.1 years after 1990, which puts us in kind of 2051 or early 2052. Then if I want to get the number of inmates, I just substitute 61.1 back into the function, and if I do that I get 3,818,399.6, which we know we probably can't have 0.6 inmates, so we would probably say 3,818,400 approximately. And again, this is a modeling formula, may not work perfectly. Now I have a part B. When will there be, or when are there, 2 million inmates in prisons? Well, clearly that's happening. We're getting 3.8 million in 2051-ish, so I would expect that this might occur between now and then, and then there might be another point later on. So how do I solve this? Well, I set the equation equal to 2 million. Now I have an equation I want to solve. So it's a quadratic equation, so I get 0 on one side, so I subtract 2 million. And if I do that, it gives me negative 716.2 x squared plus 87,453.7 x minus 851,298. And then I use the quadratic formula. And I didn't do all the work out, but I would use the quadratic formula. So there is or will be 2 million inmates in prisons in about 2001, right? I take 1990 and add 10.7, and then also in 2102 I would take 1990 and add 111.4.